Hi, good morning or good morning. Pwede mo nung isipin na ano?
Hi na lang.
Hi na lang nga. Sige. Hey.
Hey.
3, 2, 1.
Hi, we are the Powerpuff Guys group and we'll be talking about vectors. Now, vectors are generally quantities with magnitude and direction as we have known in physics. So, in vector quantities, we have in our plane the x-axis, the y-axis, and the z-axis. The z-axis points toward u, which makes it a 3D plane. Now, the x, y, and z-axis are also could also be referenced as I-axis, J-axis, and K-axis. Its sign will be determined by the way how it rotates. Now, if the direction rotates counterclockwise, it will always be positive. Otherwise, if it rotates clockwise, it would be, or the direction will always be negative. These axes are always perpendicular to each other. So the x-axis is perpendicular to the y-axis, y-axis is perpendicular to the z-axis, and the z-axis is always perpendicular to the x-axis. Yeah. Now in the vectors, we have two types of product. The first one is a cross product, and the second one is the dot product. Cross products are vector quantities, which means it has magnitude as well as direction. And while dot product is a scalar quantity, which means scalar quantities only have magnitude, it doesn't have direction. Now for our configurations, in cross products, once you multiply two perpendicular axes positively, you will always get the other perpendicular axis. For example, here in our 3D plane, we have the I-axis and the J-axis. Once we multiply the I and J-axis, we'll have it like this one. It will result for this plane to move forward, which results to the K-axis. And it goes the same way with the other axes, like J cross K will always be equal to the I-axis, and K cross I will be the J-axis. Now, the sign would be different if we multiply it the other way around. For example, if we multiply I cross K, the value of the J-axis will be negative. It goes the same way with K cross J, it will be negative I, and J cross I would be negative K. It is always important to be noticeable with the direction of how we get our products, because since it's a vector quantity, direction is always matters. So I cross J always be K, while I cross K will be negative J, but K cross I will be positive J. Now, if we get the cross products of the same direction, we'll always have zero direction. So I cross I will be 0, J cross J will be 0, and K cross K will be 0. So that's the configurations for the cross product. Now let's move on to the dot product, which is a scalar quantity. Now let's remember that scalar quantities only have magnitude and doesn't have direction. Since we're talking about vectors, it is expected that every dot product would always equate to a zero direction since it's scalar. So whenever we multiply any of the axes to the other axis, for example, I dot j will always be 0, j dot k will be 0, and the rest goes on. It would always be 0 since it is scalar. But contrast to the cross product, if we get the dot product of the same direction, we always have the value of 1. So I dot I is equal to 1, j dot j is equal to 1, and k dot k is equal to 1. So that's the overview of vectors, and we'll have sample problems about addition, subtraction, the cross products, and the dot products.
So I'm going to discuss the addition of vectors. Basically, from the word itself, addition, we're just going to combine the like terms of vectors. So for example, A, we've got 5i plus 6j plus 7k. Another is B. In B, we've got 10i plus 11j plus 12k. So now we're gonna combine the two like so. And it's going to be just a simple addition of combined like terms. So 5i plus 10i is equal to 15i. Yay! And now 6j plus 11j is equal to 17. 17j, yay! And lastly, 7k plus 12k is equal to 19k. And that's basically it. It's an example. So we're going to do another example. I plus 2j plus 16k. In B, we've got 10i again, 20j plus 2k. So again, it's just addition and combined like terms. So 10i plus I is equal to I, 2j plus 20j is equal to 22j, and lastly 16k plus 2k is equal to 18k. So that's it for the addition of vectors.
So, as we've learned about addition of vectors, we're going to discuss now about the subtraction of vectors. So, here we have the examples. A is equal to 5i minus 4j, B, 7i plus 8j, C, 3i minus 2j. So, just like addition of vectors, we are going to manipulate those with like terms. So, subtraction. Example, A minus C. So 5i minus 4j minus B 7i plus 8j. So transpose negative 7i minus 8j. Subtract like terms, 5i minus 7i equal to negative 2i. Negative 4j minus 8j is equal to negative 12j. So we are done. This is the answer for A minus C, A minus B. So for another example, let's subtract B minus C. So B minus C. So first are B, 7i plus 8j minus our C minus 3i minus 2j. So 7i plus 8j minus 3i plus 2j. Negative times negative. So subtract like terms, 7i minus 3i, 4i. 8j plus 2j plus 10j. So this is our B minus C. So let's try a more complicated example. A minus quantity B plus C. So since it is B plus C is inside the parentheses, we are going to manipulate first the inside. So B plus C, or B 7i plus 8j plus our c 3i minus 2j. So 7 combined like term 7i plus 3i is equal to 10i plus 8j minus 2j is equal to 6j. So this is our b plus c. So we are going to subtract a minus b plus c. Since we already have our b plus c, we can subtract our a with this. So a is equal to 5i minus 4j minus 10i plus 6j. So 5i minus 4j negative 10i minus 6j. Subtract like terms, 5 minus 10, negative 5i, negative 4j minus 6j, negative 10j. So this is our answer for A minus quantity B plus C.
So we're gonna have some sample problems in dot product. So to find the dot product between two vectors, you're gonna need to multiply the coefficients with same variables and add a node. So a sub I times b sub I plus a sub j plus b sub j. So a sub I times b sub I 2 times 3 plus a sub j plus b sub j 5 times 1 negative 3. So 2 times negative 3 is 6 and 5 times 1 is 5. So negative 6 plus 5 is equals to 1. So that is the dot product of A and B. So here's another example of dot product. So to find the dot product of two vectors, we're gonna need to multiply 5 times 7 plus negative 4 times 2 plus 3 times negative 8. So 5 times 7 is 35 plus negative 4 times 2 is negative 8 and 3 times negative 8 is negative 24. So 35 minus 8 minus 24 is equals to 3.
Okay, so lastly, we're going to talk about cross product. So cross product is getting the value of the other perpendicular. So we'll have it like this. Let's have some sample problems. For example, we have A is equal to 3i plus 5j minus 7k, and B is equal to 2i minus 6j plus 4k. Now, if we get the cross product of A and B, we'll always have the other perpendicular, which is C. So, finding for A cross B is also finding for the value of C, or the equation of C. So, the procedure to find the value of C is by using basket method in matrix. Now, we can use the basket method like this. So we'll plot it like this, I, j, k. Then we'll have the coefficients of the first, of the A. So we'll have 3, 5, and negative 7. And the B will be 2, negative 6, and 4. So this is a matrix, so we put it like this. And this will be equal to C, as we have shown in A cross B is equal to C. Now, since this is a square matrix, the way that we could perform a basket method is to repeat these first two columns on the right. So we'll repeat this here. So this is going to be I, 3, 2, and J, 5, negative 6. Now, batch method, we will multiply the first diagonals downwards. So we'll have this one, this one, this one. And next we're going to multiply the diagonals upward. So this one, this one, this one. After getting their products, we're going to add them all. So let's first do the downwards diagonal. So I times 5 times 4 will be 20i. Negative 7 times 2 times j is negative 14j. And negative 6 times 3 times k will be negative 18k. Now this is our lower equation. So let's find the upper one. So 2 times 5 times k is 10k. Negative 6 times negative 7 times I is positive 42i. And lastly, 4 times 3 times j is positive 12i. J. 12j. Now, to find for c, for the value of c, this is going to be our upper equation. We're going to use this process. So it's going to be lower minus upper. So we're going to have 20i minus 14j minus 18k and minus, and let's just put the corresponding variables down. So 10k will be here, 42i will be here, and lastly 12j will be here. This is positive and positive. So since this is a subtraction, we will negate this equation and it will change its signs. So you just change the signs here. It's going to be negative. It's going to be negative. It's going to be negative. So let's just remove this parentheses. There. So we're going to subtract these equations with G. Now 20i minus 42i will be negative 22i. Negative 14j minus 12j will be negative 26j. Lastly, negative 18k minus 10k will be negative 28k. Now this answer will be our C. So that's the process of finding the C by using the cross product. So it means that this is the equation perpendicular to both A and B. So let's have another example. Now on our previous example, we have found the product, the cross product of A and B. Now let's try what would happen if we inverted the equation, inverted the process, and let's find B cross A. Let's find this value, if it's still going to be C or it will be different. Now, since the process will be like this, again, I, J, and K, the only difference is that we're going to be first prioritizing B. So we have 2, negative 6, and 4. And A will be 3, 5, and negative 7. So this is our matrix. This is a square matrix. We'll use the basket method to find its determinant. So let's try it again. We'll use the downward diagonals first. Let's rewrite the first two columns first on the right. So it's going to be I, 2, 3, and J, negative 6, 5. Now let's get the determinant by using the downward diagonals. So this one, this one, this one, this one, this one. Okay, so negative 6 times 7 is negative 42i. 4 times 3 times j is 12i. And j pa. 12j. 5 times 2 times k is 10k. Now, upward diagonals will have negative 6 times 3 times k is negative 18k. 5 times 4 times I is 20i. And finally, negative 7 times 2 times j is negative 14j. Now again, we're going to use the procedure lower minus upper. Lower minus upper. This is our lower product, and this is the upper one. Now, since our lower is this, we're just going to copy it here. 42i plus 12j plus 10k. Now, we will subtract. The upper one will be negative 18k is here, negative 18k, 20i is here, and actually 14j is here. So we get the answer here. So we're gonna change the sign since it's subtraction. We're gonna negate this equation here. So we'll just distribute the negative sign. This is negative, this is a positive, this is positive. So let's just remove this one. And there you go. Or maybe we can just add this one. Yeah. Now let's add these equations. We'll have negative 62i plus 28j plus 26j and 28. Okay. So if notice, it's a different answer right now because we're dealing with cross product, which is a vector quantity. Which means direction always matters. Since we inverted the axis, we first prioritize B, then A, it would always be different than the answer of A cross B. So there's that. So A cross B, what I'm saying is A cross B will be different from B cross A. There you go. So we'll have other examples. So for our last problem, we're going to be talking about cross dot product. So cross dot products are used to find the volume of a certain figure, which is of a parallelogram nature. So for example, we have this cube, or maybe we can determine it's a parallelogram. You have the a-axis as our previous examples, as well as so a would be 3i plus 5j minus 7k, and the b-axis is 2i minus 6j plus 4k. And as we have solved previously, the c-axis is equal to negative 22i minus 26j minus 28k. Now, to find the volume of this figure, you can actually find it by using this formula. You're gonna do it as C dot the product of the C dot quantity of A cross B. So this would be A cross B would be equal to C, as we've known with the configurations a while ago. So we're gonna have C dot C. And finding the value of C dot C would equal to the volume of this figure. So let's try that. So C dot A cross B will be equal to C dot C. Like that. So let's find the cross product of the dot product of C dot C. Then do it here. And we can do it here. So C is a negative 22i minus 26j minus 28k, and now C dot C would be equal to C C sub 1 times C sub 1 plus c sub 2 times c sub 2 plus c sub 3 times c sub 3. So this, since these are just the same values, we can just square them. Because we written as c1 squared plus c2 squared plus c3 squared. So let's put in our values. Let's substitute the values here. So c1 is negative 22 squared plus c2 is negative 26 square, lastly negative 28 is c3. So negative 28 is so square. Now we can find each values by using a calculator. So let's try that. Negative 22 square is equal to 484. Next, negative 26 squared is equal to positive 676. Lastly, negative 28 squared is equal to positive 784. Now you just get the sum of these three values, and we will have 44 plus 676 plus 784 will be 1944 in scalar quantity. Now this is a scalar quantity because we're looking for a volume. So since this is a volume, there should be a unit. Since we don't really have a unit for this problem, we can just write it as cubic units. So this is the way of finding the volume of this figure when the equations of the axis are given. So that concludes this tutorial for vectors. We hope that you've learned so much from this discussion. Thank you. We are Powerpuff guys again. Goodbye.